Okay, guys. So we are looking at trying to find the area of certain values in a normal distribution. And if you guys recall, we talked about z-scores telling us like how many standard deviations a value is away above or below what the mean is. And I can use this value, I can use this z-score to kind of help find probabilities of certain events happening. Okay? And so what we're doing is when we find the z-score, what we are creating is like a standard normal distribution. So instead of me like looking at this curve in which we have a mean of 6.84 and we have like the distance from one standard deviation being whatever the difference between 6.84 and 5.29 is, like we end up changing it until like we are standardizing it so that it has a mean of 0 and that first standard deviation to the left is -1. So a standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. So that is using that idea of a z-score to help find probabilities of certain events happening. So let's just look at one example. Before we do that, if you guys look on page 29, these are the steps that we're going to follow to like find the areas in any normal distribution. So the first thing that we're going to do is we're going to draw a normal distribution curve. And we're going to just sketch it roughly. It doesn't have to be perfect. In this case, we're going to read, it says that in 2016, more than 1.6 million students took the SAT. The distribution of the scores out of about 800 follows an approximately normal distribution in which it has a mean of 508 and it has a standard deviation of 110. So like if I look right here, we will say that that mean is 508. Okay. And in this case, we do know it's a normal distribution. And symbolically, when we write this, we will say that it's a normal curve, which it has a mean of 508, and then it has a standard deviation of 110. So this is going to be your notation when we identify different types of distributions, which we'll talk about like binomial and geometric as well. So this is going to be important, like when we kind of telling me or whoever's grading anything that you have, that you understand what type of distribution it is. That this is a normal distribution, which it has a mean of 508 and a standard deviation of 110. Okay? All right, so in this case, we're trying to find out about what percent of students who took the SAT scored less than 350 on the SAT. All right, so if I were to look at this curve, I'm going to just roughly sketch 350. We'll say that 350 is like right here, okay? And we're trying to find the probability that the score, like what percent of students took the ACT, scored less than 350. So we're looking kind of like at this area right here. And we want to find out what that is. So today we talked about like using the empirical rule to help identify that, but we can also use like our z-score to help find that. So that's what we're going to do next, is we're going to perform our calculations. So I do know that z is going to equal, and we talked about how z equals whatever your score is minus the mean over our standard deviation. So in this case, we're going to take 350 minus 508, and we're going to divide that by 110. So as we do this calculation, if I just use my calculator, 350 minus 508 divided by 110, what happens is I get a z-score of approximately -1.44. So what I can do is I can use something called using a z-score chart to help identify what percent is to the left of that specific z-score of -1.44. So what I'm going to do is, if you guys look at the packet that one of the packets I gave you at the beginning of the year, the formula packet, if you guys go to table A, you guys will see something like this, okay? And this is for standard normal probabilities. And what I want to do is I want to find -1.4, so -1.4. So -1.4 is right here. and I'm going to stop where it is 0.4. So what it looks like is that percentage is 0.0749. So what that means is that the area underneath this curve is 0.0749. That is that area of that curve, okay? Remember we talked about different types of distributions earlier today, just finding the area underneath that part of that curve. So in this case, it looks like we have 7.49% of students who took the SAT scored less than 350 on the math section. All right, so that's when we're trying to find the area, like first values that are less than. We're going to sprint ahead and we're going to look at something in which we are trying to find the area of something that is greater than. So in this case, we're still dealing with the same type of information. We still have a normal distribution, so we're going to draw that normal curve. I do know that my mean is 508, and my standard deviation is 110. So I do know that 508 is right here, approximately. And I am trying to find what percentage scored at least 730. So I'm just going to change my color. I'm going to go 730s like right here, okay? So in this case, I'm trying to find the values that are greater than 730. So we're going to find our z-score first. So we're going to take 730 minus 508 divided by 110. And when I do that, I got a z-score of 2.018. So when I look at this table, I am going to go and look at the second page of table A. And I'm looking for, I guess we'll say it's 2.02. So I'm going to look at my table. So I'm looking at 2.02. So I'm looking right here. And it looks like that probability or the value underneath that curve is 0.9783. So what that's saying is, like, if I look at to the left of this, like if I were to ask you guys what the area of this part of the curve is that is 0.9783. But in this case, because we're trying to find values that are at least 730, so that means we're looking at 730 or higher. So we're trying to find, the probability of an event that's being greater than 730. In this case, I'm going to take 1 minus 0.9783 to find that probability. And I get that to be 0.0217. So what I could say is that 2.17% of University of Michigan students got the recommended SAT math score of at least 730. Okay? All right, so now what we're going to try to do is, like, if it's saying it's bounded between two specific values. Okay? So what we're going to do in this case is we're trying to find that they got a score in the 500s. Okay? So really, we have the same basic idea. We have 508 And we're looking at like 500 all the way up to about 600. So we're trying to find the area underneath this part of the curve. Okay, so this is still normal, and in this case we got 508 and we got 110. So the first thing that we're going to do is find the z-score for each of these. So we're going to do z equals 500 minus 508 over 110, and then we're going to try to find the probability of 600 minus 508 divided by 110. So in this case, we got a z-score of 0.07. And in this one, when I do that one, I got 0.84. Okay. So, like, I know that this z-score is, like, this is where z equals 0.07. And I know that this is where z equals 0.84. So I'm trying to find the probability that falls within those two. So the first thing I got to do is find out what percentile is 0.07. Negative 0.07. That's what that was. Okay. So we're going to look at our chart. We're going to go to negative 0.07, which I don't have. So we're going to pause this for a second. I went to negative 0.07, and it looks like I have a z-score of 0.4721. And then I also did the same thing for 0.84, and it looks like that percent is 0.7995. So let's kind of go back here. And I know, like right here, that I got this to be, like from here to here is 0.4721. And then I know from here all the way to where 0.84 is, that value is 0.7995. So to find the value in between that, we're just going to subtract those two values. So I'm going to say 0.7995 minus 0.4721. And I got that to be 0.3274. Okay? So what this tells me is that 32.74% of students scored in the 500s on the SAT math section. So here's what I'm going to ask you guys to do. I'm going to ask you just to try to check this question on page 127. I think there are 3 parts to this question. So try that, and we will go over that when I see you next. Have a great day.